Just a short video of a Nixie Clock project that I've been working on for a little while now, and where I'm up to. So basically got everything working. This is just a test code for bringing the board up to check that the all of the segments are working. They're end-on Nixie tubes. They're running at about 180 volts, and a couple of way too big neons as well for the flashes, for the codons on the clock. And everything's individually addressable. The grey cardboard is just a simple, just a mock front panel, being ginger when I take these out. Should give you a bit of a view. There's two boards together in a sandwich. They bolt together. You can see the tubes there themselves, so they're end on. Okay, if I pull the power cable, it's just 12 volt DC going in. I carefully pull this. Give it a few minutes because there's some high voltage on here. Now try and difficult with the camera. So unplug the two boards. We'll start by looking at this one. This one's the display board. So it's got a couple of drivers on it, and these are Microchip, or a company that Microchip recently bought out. They're HV5222. They're high voltage shift registers. They're really quite nice chips, and certainly a firm favourite of mine because you don't have to solder hundreds of transistors onto drive Nixie tubes. They're 220 volt, slightly higher transient suppression, and they do 100 milliamps per pin as well, so they're quite beefy devices. I think each one of these is 64 pins as well, so from memory. But yeah, they're quite good devices. The clock will up to about 800 about 80 megahertz from memory. So they're really quite fast chips. Maybe it's only 8 megahertz actually, but certainly well fast enough to do any kind of fading effects and dimming and that kind of thing on there. They've also got blanking outputs and stuff like that. So that's the top layer of the board. And the bottom of the board here, and the bottom section of the board, contains a 12 volt to 180 volt switch my power supply here. Most of it's under the Captain tape just to protect my fingers when I pick the board up, and don't want any zapping. And there's a sorry, move my hand out so it focuses properly. There's a DS3232 Max in Dallas chip. That's a real-time clock. It's one of the extremely accurate ones, and the Arduino Pro Micro. So I can program the thing over USB, set the clock. That will program the real-time chip via a quick web script or a quick Python script or something to program the real-time clock chip, and then it will run happily for. So far, I've got another one going for a couple of years that keeps really good time. So I'm very pleased with those. I think they're just temperature compensated as well, and there's a battery on the reverse side of the board here that keeps the clock running when it's not powered. So it's pretty simple to do. It's fairly cheap to build, and quite a nice little unit. It's nice and small. I built it to go on my desk at work just before the lockdown happened. The COVID-19 lockdown happened in early 2020 in the UK, and since then I've not been back in the office. So, but a couple of people were asking me about projects and stuff, and I thought I'd make a quick video showing you the basis of this one.